Hello, welcome to another lesson from my course on networking fundamentals. The first module of this course will teach you everything you need to understand how data flows through the internet. In this video, we're going to continue our lesson discussing everything hosts do to send data on the internet. Now, before watching this video, it is recommended to have watched Lesson 1 and Lesson 2 from this series. This lesson uses and elaborates on many of the concepts introduced from prior lessons. Also, you should have already watched Part 1 of this lesson. This video is a direct continuation. In Part 1 of this lesson, we illustrated everything hosts do to communicate to other hosts on the same network. In this video, we're going to add a router, and we're going to show you everything a host does when trying to communicate with another host on a foreign network. We're going to use this topology to show you everything host A does to send data to host C. Both of our hosts and our router has a MAC address and IP addresses. And once again, I'm only showing you the short version of the MAC address to conserve screen real estate. Now this /24 you see on all of them is simply another way of representing this subnet mask. And again, the subnet mask simply defines how big a particular network is. All of this is a function of subnetting, and once again we are not going to be covering subnetting in this module. In the first part of this lesson, we mentioned that anything with an IP address has an ARP cache. Well, host A, the router, and host C all have an IP addresses, so all three of them have an ARP cache. But this video, we're going to be focusing on host A, so we're only going to show you host A's ARP cache. And we're going to show you its functionality, as host A has some data to send to host C. Now, host A already knows host C's IP address. We mentioned some reasons for this in the last video, but essentially, that IP address could have been provided by the user or provided by the application that is creating this data that is meant to be sent to host C. One way or another, host A already knows the IP address it's trying to speak to. But in particular, host A knows that that IP address is on a foreign network. It's going to know this by looking at its own IP address and subnet mask and comparing it with a target IP address. That's how it's going to know this IP address is on a foreign network. Now once again, all of that is done through the magic of subnetting, and if you're interested in knowing how that works, check out the videos at subnetipv4.com. But insofar as this video, go ahead and take my word for it that host C's IP address is indeed on a different network than host A's IP address. Either way, since host A knows the IP address it's trying to speak to, host A is able to create a layer 3 header identifying the two endpoints of this communication. That layer 3 header is going to have a source IP address of host A and a destination IP address of host C. Next, host A needs to create a layer 2 header. The purpose of the layer 2 header is going to be to take the packet from hop to hop. In this case, since the target we are trying to speak to is on a foreign network, our next hop is going to be the router. Meaning, the purpose of this layer 2 header is going to be to get this packet to the router. The problem is at this point in time, since host A's ARP cache is empty, host A is unable to complete the layer 2 header that'll take this packet to the router. Host A, just like before, is going to have to use ARP to resolve the MAC address of the router. But there's something we have to mention. How does host A even know the router's IP address? Well, the answer to that is that the router's IP address is already configured on host A as host A's default gateway. When you connect a computer to the internet, there are three things that you have to configure: an IP address, a subnet mask, and a default gateway. On a Windows computer, if you type ipconfig into the command prompt, you'll see all three of these things listed. Here, I'm showing you exactly what it might look like on host A itself. Notice the IP address matches host A's IP address, the mask is a /24 mask, and in particular, the default gateway is highlighting the IP address of our router. That's how host A knows the router's IP address, because it's been configured as its default gateway. That's the IP address that host A is going to have to resolve with ARP. So just like we mentioned in the last lesson, host A is going to shoot out an ARP request. That ARP request is going to ask for the MAC address that correlates to a particular IP address. And again, host A is going to include its own ARP mapping in the request itself. That ARP request is going to get to the router, and then the router is going to generate a response. That response is going to include the mapping that host A was interested in learning. The IP address 10.1.1.1 maps to the MAC address E5E5. And when that ARP response arrives on host A is able to populate its ARP cache with the mapping for its default gateway. It can then use this mapping to complete the layer 2 header. the destination MAC address for that layer 2 header is going to be the router's MAC address. This will allow this header to handle hop-to-hop delivery of this packet. And now that data can finally be sent across the wire where it will be received by the router. Upon receiving this, the router is going to discard the layer 2 header. The whole purpose of that header was to get this packet from host A's NIC to the router's NIC. That header did that successfully and can go and retire happily in header heaven. And at this point, the router is going to take over. Presumably, the router is going to add layer 2 headers as necessary to get the packet across the next hop, whether that hop is directly to host C or whether that hop is across multiple routers on the internet. One way or another, from host A's perspective, the job is done. It did everything it needed to do to get the data to the router, and from here, we're just going to hope that the router can do the rest of the work to get it all the way to host C. Now, I want to highlight something important for you. This ARP entry that host A resolved in order to get the packet to the router can be reused to speak to any host in foreign networks. So let me show you what I mean by that. So here again is the layer 3 and layer 2 header that were used to get this data to host C. And let's go ahead and add other hosts to our topology. Let's say now host A is going to be trying to speak to host D. Well, since this is a new endpoint, we're going to need a new layer 3 header. This layer 3 header is going to have a source IP address of host A, as before, and of course a destination IP address of host D. But notice the layer 2 header doesn't change. Host A's first hop is always going to be to the first router, and therefore the source MAC address and destination MAC address are always going to identify those two NICs. So this ARP process that we had to go through to resolve the router's IP address really only needs to happen once. Once host A knows the router's MAC address, it can reuse that MAC address to speak to any host in a foreign network. In all cases, the layer 2 header is going to look the same. So it's important to understand this ARP process is very crucial to how data moves through a network. It's actually the first step that host A or any host takes when it's trying to send data on a network, is to determine if the target IP it's trying to speak to is on my own network, the local network, or a foreign network. If it's on a foreign network, like we just showed you, ARP is going to try and resolve the default gateway's IP address. And if it's trying to speak to something on the local network, ARP is going to try and resolve the target IP address directly. That's actually the illustration we showed you in part 1 of this lesson. We showed you that for host A to speak to host B, the ARP entry that host A had to create was for host B's IP address directly. This is what allowed host A to create this layer 2 and layer 3 header to get data from host A to host B. And that wraps up our lesson on everything hosts do to speak on the internet. The key points of this lesson was understanding what hosts do when speaking to other hosts on a local network or other hosts on a foreign network. And in particular, understanding how the layer 3 and the layer 2 headers are populated to get the data to the other host. Moreover, you should also understand ARP's role in this entire process. If you understand these 3 key points and you followed all the concepts in this lesson, then you now know everything hosts do to communicate with other hosts in the same network, regardless of how they are actually connected, and everything hosts do to communicate to other hosts in foreign networks, regardless of how they are connected. In the next lesson, we're going to take the focus away from hosts and instead look at these devices right here. We're going to unpack everything switches do to facilitate communication within a network and everything routers do to facilitate communication between networks. But that's it for this lesson. I hope you enjoyed this video. I want to thank you for watching, and we'll see you in the next one. Hey YouTube, I hope you enjoyed that free lesson from my new course on networking fundamentals. I'll be releasing the entire first module for free here on YouTube. I want this course to be the ultimate networking fundamentals course, and since I'm still scoping out the outline, you could have a say in what topics will be covered. Let me know in the comments below what subjects you want included in this course. Otherwise, remember to like and subscribe. And of course, if you learned something from this video, the best way to thank me is to share this video. It's a small act of gratitude, but one I appreciate greatly. I hope you enjoyed this lesson. I want to thank you for watching, and we'll see you in the next one.